Greenhouse gas, GHG, emissions from dairy cattle, particularly methane, CH4, released during enteric fermentation, significantly contribute to climate change. As countries adopt climate-smart agricultural practices, feed additives have emerged as a promising solution to reduce methane emissions from cattle. These additives work by modifying the rumen environment, inhibiting methane-producing microbes, and improving feed efficiency. One of the most promising categories is nitrate-based compounds, which compete with methanogens for hydrogen in the rumen. Instead of producing methane, these compounds generate ammonia, significantly reducing methane output. However, careful management is necessary to avoid nitrate toxicity. Another effective strategy is the inclusion of fat and oil supplements, such as coconut, linseed, and palm oils. Fats suppress methane production by reducing hydrogen availability for methanogenesis, while also boosting the energy content of the feed. However, excessive fat can impair fiber digestion, so balanced feeding is essential. Tannins, natural compounds found in plants like leucaena and calliandra, bind with proteins in the rumen, making them less available for microbial degradation and methane production. These compounds also improve protein utilization efficiency, but must be used judiciously to avoid adverse effects on animal productivity. Recent research has also highlighted the effectiveness of essential oils and spices, such as garlic and oregano oils. These natural antimicrobials reduce methanogen populations in the rumen, suppressing methane formation. Additionally, 3-NOP, 3-nitrooxypropanol, has shown remarkable results by inhibiting the key enzyme involved in methane production, achieving up to a 30% to 50% reduction in methane emissions, without compromising animal health or productivity. Perhaps the most groundbreaking innovation involves seaweed additives, particularly species like Asparagopsis. These seaweeds contain bromoform, a compound that interrupts methane production pathways in the rumen, with some studies reporting reductions as high as 80%. However, challenges remain in scaling up seaweed production sustainably. Several tropical countries have already made significant progress in adopting feed additives to curb emissions. In Australia, seaweed-based feed additives are being trialed with highly promising results. Brazil has integrated nitrate supplements and tannin-rich feeds into its pasture-based dairy systems, while India promotes the use of essential oils and tree foliage containing natural tannins to reduce emissions in rural dairy farms. Closer to home, Sri Lanka has piloted the use of coconut oil and tannin-based forages, leveraging the country's abundant natural resources. In Indonesia and Malaysia, palm oil byproducts are being tested for their methane-reducing properties, showing potential for wider adoption across Southeast Asia. Feed additives reduce methane emissions by capturing hydrogen, a key element in methane formation. Compounds like nitrates and fats divert hydrogen towards safer byproducts, while additives such as 3-NOP directly inhibit methane-producing microbes. By altering the rumen microbial population, these additives encourage more efficient nutrient absorption, leading to improved feed conversion and higher productivity per unit of milk produced. While feed additives are showing great promise, challenges remain in terms of regulation, cost, and dairy farmer adoption. Ensuring affordability and accessibility for smallholder farmers is essential for large-scale adoption in tropical regions. Additionally, further research and development are needed to optimize these solutions and explore new natural additives. As the dairy industry seeks sustainable ways to reduce its environmental footprint, feed additives are poised to play a crucial role in advancing climate-smart dairy practices. Their success will depend on collaboration among researchers and dairy farmers, driving innovation for a greener and more sustainable future.